Today we're discussing the algebra of functions, and this just means basically we're going to be doing some mathematical operations, addition, subtraction, multiplying, dividing, and what is called composition. And so we're going to start out with some limitations here. If the domain of f is A and the domain of g is B, so we're given a set A, and all the values that we can put into the function f come out of A, and then we're given a set B, and all the values that we can put into the function g come out of the set B. The first thing is that if we want to add f plus g of x, all we do is we simply add f of x plus g of x. We just do the individual functions and add them together. And then you can see that our domain is the intersection of A and B. In other words, for us to be able to put something into f plus g of x, it has to be a part, that's what the intersection means, that it's in both. It's in both A and it's in B. We look at f minus g of x. And again, you just take them individually and subtract the two. And also, again, the domain is simply A intersect with B. We look at f times g of x. And again, that's f of x times g of x. You just do them individually and then multiply them together. And again, our domain is A intersect B. We're getting repetitive here. The one that's a little bit different is this one. F divided by g of x. And that is, this part's the same, f over x, or sorry, f of x divided by g of x. Just do them individually. But the domain here is, if you'll notice, we've got A intersect B still, so it's all the values of x that are in A intersect B, and we have an additional limitation. G of x cannot be equal to 0. And of course we know that because in algebra, or anything, we're not allowed to divide by 0. We can't do it. It's impossible. And so those are the limitations. We don't have tons of limitations. The biggest one is on the division problem there. So now we want to simplify the following expressions, and we're given that f of x is 1 over x minus 2, and g of x is the square root of x. So f plus g of x. Well, all we do is we take f of x plus g of x. And so for this problem, that's 1 over x minus 2 plus the square root of x. Okay, and really that's all. We can't simplify that, so we're just going to leave it the way it is. And then if we want to think about our domain, the domain for f of x is going to be all numbers except, remember we can't let that equal 0, so x cannot be 2. The domain for g of x, the stuff inside of a radical, remember the limitation there is that has to be positive. So that thing inside the radical has to be greater than or equal to 0. So our domain overall for these two functions put together, the overall domain is going to be the set of all x's such that x is greater than or equal to 0 and x does not equal 2. Okay, so that's the intersection of those two domains. Looking at part B, again, we've got f of x minus g of x. So this is just 1 minus x minus 2, 1 over x minus 2 minus the square root of x. And as we see that, our domain, again, if you remember, it was just the intersection. Anything that we can plug into both of those functions is okay to plug into the subtraction. Part C, f times g of x. So again, 1 over x minus 2 times the square root of x. Well, this one we can simplify a little bit because this is square root of x over 1. That just gives us the square root of x over x minus 2. Again, the domain, it's just the intersection of those. And then our last one that we've got is f of x or f over g of x. So we have f of x, 1 over x minus 2, over the square root of x. Well, here we've got a complex fraction, and we don't really like that a whole lot. So what we're going to do is to get rid of that, we multiply by the reciprocal of the denominator. And we do that on the top and the bottom of our fraction. And the reason we do that is, notice what happens here, they just cancel out. So we have a 1 left down there, which we don't have to write. So then we have 1 times 1, and then we have x minus 2 times the square root of x. Okay? So that is the simplified function. But then we want to talk about the domain. Remember, our domain for all of them was this right here. The one additional point is that for division, we can't let g of x equal 0. And so that alters this right here. We can't let the square root of x equal 0. So we have to eliminate the value x equals 0. That's the only time that happens. So our domain for part D is going to be exactly the same, x, such that x is greater than, but this time it can't be equal to 0. So just greater than 0, and x is not equal to 2. So we just have one additional little limitation there for part D. Now we want to try this with some specific values. So f plus g of 4. Well, again, just as a reminder, that just means f of 4 plus g of 4. So f of 4 means we plug in a 4. It'll be 1 over 4 minus 2, because, again, 4 is our input value, plus the square root of our input value, which is 4. So this is 1/2 plus 2, so our answer is 2.5. Just adding those together. For the next one, we already actually know what f of 4 is. F of 4 we figured out is 1/2. We did that work right here. So we don't have to do it again. So we have 1/2 minus, and we already know g of 4 is 2. So that's going to give us negative 1.5. When we have f times g of 4, remember that's f of 4 times g of 4. We already know what f of 4 is. It's 1/2. We know what g of 4 is. It's 2. And 1/2 times 2 is 1. And then finally, if we want f divided by g of 4, that's f of 4 divided by g of 4. And that gives us 1/2 divided by 2. And again, with a complex fraction, maybe we know 1/2 divided by 2 is 1/4. But if we're not sure, multiply by the reciprocal of the denominator. This cancels to a 1, and so 1/2 times 1/2 is 1/4. Okay, if the graphs of functions are available, the functions can be added by adding the values of the functions at each particular x value. And we're going to take a look at this. You can also subtract them. So if you've got the picture, we can do some things algebraically. Multiplying and dividing would be a little bit more difficult, but you could do those too. So we're going to find f plus g of x given the following graph. Okay, here's our graph, and we are adding these two together. So if I first of all look at f of x, the value of f of x when x is 0, if I go up here, the value is 4. And the value of g of x when x is 0 is 1. And so 4 plus 1 is 5. So my first point will be right there at 5. When x is 1, notice we've got that value plus 2. So it's really 3 1/4, basically, 3 1/3 plus 2, which gives us 5 1/3. So we'll go up here to 5 1/3, and our next point is going to be right there. When x is 2, we've got 2 2/3 plus 1. So that's going to be 3 2/3. which is right there. When you've got x equals 3, that gives us 2, and then 0. And 2 plus 0 is just 2, so that's going to give us a point right there. When x is 4, we've got 1 3/4, and we've also got, looks like, just 3/4. So that would give us 2 1/2. Should be right there. And here we have, when x is 5, 2 1/2 and 2 1/2, which gives us 5. Oh, that's not 2 1/2. It's 1 1/2 and 1 1/2. Sorry, which gives us 3. And what we find out is here, actually, we only have to put a new dot in when one of them changes direction. So I'm going to wait. Notice this is a straight line all the way from here to here. And from there, so I'm just going to go to this one. When x is 7, we get a 1, and we also get a 3. And 1 and 3 is equal to 4. So we've got that. And then lastly, when we get to x equals 8, we've got 2 plus 3 is 5. And that gives us that right there. So then we're just connecting the dots. So we got here, and oh, my line is crooked. And then we've got this, and then we've got this. So you'll see a little better picture when I push this button here. Okay, so we get that value, and we can see that visually we can add these things together, and if it makes sense, you're just adding the y values together, and so it just makes the graph increase. So for composition of functions, this is one that's new, and it's not just adding, subtracting, or dividing, but composition of functions. This is f composed of g of x. And what that means is we're going to apply the g function to x first, and then once we get that answer, we're going to then take that answer and apply the f function to it. So hopefully that'll make sense as we go through some of these examples. So we want to simplify this. We're given, simplify the following compositions and find their domains. So f composed of g of x. As we look at the first one, that's f of g of x, which means the g function gets applied first. So g of x is x minus 3. So all we're doing is replacing the g of x with the x minus 3 because those are equal to each other. And now what does the f function do to anything you put into it? Well, it takes the input value and squares it. So that's x minus 3 is our input value, and when we square that, we do have to FOIL it. It's x minus 3 times x minus 3, and that gives us, I'm not going to take the time to FOIL it, but it's x squared minus 6x plus 9. Hopefully we're at the point where we know how to FOIL already. And so that is f composed of g of x. As far as domains, the domain of this one, r squared, is all real numbers. The domain of x minus 3 is all real numbers. So if we take the composition of them, that's still going to be all real numbers. Next we've got g composed of f of x, so that'll be g of f of x. And so that is g of x squared. Okay, because again, f of x equals x squared from right here, so we can just replace that. And then the g function takes whatever you put into it and subtracts 3. So in this case, that's just x squared as our input value minus 3. And again, since there's no limitations on the original two functions and there's no limitations on our answer, we get that the domain is all real numbers. So now f composed of g of 5. Well, that means f of g of 5. And so the first thing we actually have to do here, and I'm going to kind of do an aside, g of 5, what is that? Well, g of 5 means we're going to take, the g function takes the input value minus 3. So that's going to be 5 minus 3 equals 2. So now we know that g of 5 is equal to 2. So now we apply the f function, and it's f of 2, and the f function takes whatever you put in, and it squares it. So 2 squared is 4. So f composed of g of 5 is equal to 4. The last one on this slide, g composed of f of 7. So g of f of 7. First, we have to know what is f of 7. So remember what the f function does. It takes your input value and it squares it. So since we're putting in a 7, that'll be 49. Now we apply the g function, because we now know that f of 7 is 49, so we have to have g of that 49. And remember what the g function does. It takes the input value and subtracts 3. So 49 minus 3 is 46. So composition of functions is really like when you follow instructions, you just do the one instruction first, and then you do the other instruction second. It's kind of like following directions, putting something together, and they're numbered 1 and 2. Well, the one that's numbered 1 here is the one closer to the x, and the one farther away from the variable is the one that you do second. All right, with this one, let's talk about the domains right away first, because we know the domain of this one is that x has to be greater than or equal to 0, because we can't take the square root of a negative. Well, the same thing happens here. 2 minus x has to be greater than or equal to 0. So when we simplify that, that means 2, we add x, 2 is greater than or equal to x, which is x is less than or equal to 2. So that's our domain for that one. So when we look at these, we're going to have to consider those domains. So the first one, f composed of g of x. So that's f of g of x. And that's going to be f of, and g of x is square root of 2 minus x. Okay? So, now, when we do our f function and apply that, we're taking the square root of our input, and our input here is the square root of 2 minus x. Okay? So that's actually the answer. We could simplify that to be the fourth root of 2 minus x, but really this is all I would ask for, because we haven't done that yet. But what we want to look at is, notice here we've got two limitations. We first of all know that 2 minus x has to be positive from right here, but then since there's another radical, we know that the square root of 2 minus x has to also be greater than or equal to 0. So we need to find out, are there any additional limitations? Well, the answer is no, because by definition, this symbol means the positive answer. Okay, that was one of our definitions of square roots, so the only limitation we have for this domain is the one we had originally, that x has to be less than or equal to 2. So our simplification is this right here, and then our domain is x less than or equal to 2. For the second one, we've got g of f of x, which again is g of the square root of x, because that's what f of x equals. Then the g function takes the square root of 2 minus the input value, which is square root of x. Okay? And that's our answer. But we have to look at f of x had this limitation, x is greater than or equal to 0. But now we've got this thing, 2 minus the square root of x, and we know that has to be greater than or equal to 0. So do we have any additional limitations? Well, simplifying this, we know that 2 has to be greater than or equal to the square root of x. And this is where it gets a little bit tricky. We square both sides. And so that tells us that 4 is greater than or equal to x. Okay? So first of all, we need x to be less than or equal to 4. That's from here. But we also needed x to be greater than or equal to 0 from right there. So our domain is that x can only be between, and we'll use interval notation here, x can be equal to 0 and x can be equal to 4, but it has to be between those two values. That's our domain for G composed of f. When we look at f of x, we have f of the square root of x, and then that becomes the square root of the square root of x. And as I mentioned before, that's actually the fourth root of x, taking the square root twice. Limitations, we know the original, x has to be greater than or equal to 0. And again, the square root of x has to be greater than or equal to 0. But again, that symbol by definition means that it is. So our domain here, if we use interval notation again, we can go from 0 to infinity. That's our domain, all non-negative numbers. Now our last one, g of x, that'll be g of square root of 2 minus x, which is equal to the square root of 2 minus your input value, which is square root of 2 minus x. Okay, so that's our answer. First of all, that's simplified. But now, again, we have to consider the domain. Well, the original issue with the domain, again, has to be x less than or equal to 2. But now we have an additional limitation, because we know that 2 minus the square root of 2 minus x has to also be greater than or equal to 0. Which, again, means, as we do some simplifying, 2 is greater than or equal to the square root of 2 minus x. So again, if we square both sides, we get 4 is greater than or equal to 2 minus x. And then as we subtract 2, we have 2 is greater than or equal to negative x. And then one more simplification. Dividing by a negative 1, we get a negative 2. And we get an x. But remember, when we divide by a negative 1, any negative number, you have to switch that symbol. So that tells us that x has to be greater than or equal to negative 2. So our two limitations are x has to be greater than or equal to negative 2, but x has to be less than or equal to positive 2. And so if we're using interval notation from negative 2 to positive 2, those are the only numbers that we are allowed to put into that function. Two limitations, one from the start up here, and then one after we've simplified down here. Okay, we want to simplify the following composition, and notice we have three things. So this is just f of g of h of x. Okay, well now we have three directions to follow. We start with h of x, and we replace that h of x with x plus 3. The next one we do is now g of x, and the g function takes the input value and multiplies it, or raises it to the 10th power. So now we have x plus 3 raised to the 10th power. And then finally, what does the f function do? The f function takes the input value, x plus 3 raised to the 10th power, and divides it by the input value, x plus 3 raised to the 10th power, plus 1. So it's just we applied this function, then we applied the g function, then we finally applied the f function. And that will be our answer as we look at those. The last type of problem that we want to look at is breaking up a function. And there's multiple ways of doing this. I'll show you one way of doing it. Notice we've got an inside of the function, x plus 9, and then we've got a second part of the function that we're taking the fourth root of that. So if we want this to be f composed of g of x, we need one of these functions to just be x plus 9, input value plus 9. That takes care of this part. We need the other function to take an input value and take the fourth root of it. Now the question is, which one of these happens first? Well, your order of operations says that inside of your radical that happens first, And so in f composed of g, the g function is happening first, so we say that g of x equals x plus 9. That means the other one is f of x. And if you want to check it, go ahead and do it. F composed of g of x means f of g of x, which is f of x plus 9. Then what does the f function do to that? It takes the fourth root of the input, which is x plus 9, and we can see that those two things are the same. So this would be our f function, and this would be our g function for this particular example. Problems that are on your assignment for section 3.6, pages 275 and 276, and you see the problems listed there. There's only 8 of them, but some of them have multiple parts, so just be careful to do all the parts. And again, you will have time tomorrow in class to work on these, so go ahead and get started on those, and then you can ask questions tomorrow during class.